one right angle is 90 degree over here. Okay, and 1 degree is 60 minutes. You can say 1 minute is 60 seconds. So this is used for minute. This is used for seconds. So 1 degree is 60. Obviously, 2 pi and 4 pi are the same thing. Okay. The systems of measurement that we have, one is your sexagesimal system, or you can call it as the British system. So here what happens is one right angle. Now obviously we were ruled by Britishers, so we use this one only. One right angle is 90 degree over here. Okay, and 1 degree is 60 minutes. You can say 1 minute is 60 seconds. So this is used for minute. This is used for seconds. So 1 degree is 60 minutes and 1 minute is 60 seconds. Now next we have is centesimal. So here, since the word cent is used, so definitely something about hundreds would be there. Centesimal, you can say French. Here, one right angle means 100 G, where G means grade. Okay, sorry, not grade, grads. And 1 grad is 100 minutes, and 1 minute is 100 seconds. Now the very famous one, radian system. So first of all, 1 radian, or you can simply write it like 1. This is defined, I mean, it's approximately equal to 57 degree. See, what is the SI unit of angle?
Radian.
Okay, correct. Which angle? Plane angle or solid angle?
Plane.
Correct. And what is for solid angle?
Stir radian or something.
Yes, correct. Okay. So, this radian, or you can say pi, it has a very good proof actually. Let me tell you one thing. You know the circumference of a circle is 2 pi r, right? So can I define my pi as circumference by 2r? Wow. So that means for any circle in this world, for this also, for this also, take the circumference of it, divide it by the diameter of it. You will get this. Take the circumference of it, divided by the diameter, you will get pi. So one of this very good things. And rest, you know how to convert radian into degree and degree into radian, right?
Yeah.
Okay. Also, so we talked about pi, but pi and radians have some relation. Uh, if I talk about radian, I have a proof for this as well. You know, what do you call as 1 radian? So basically, let's say this is a center. Have you studied this formula in physics? Obviously, that if this is a radius, so this arc length can be written as theta r, correct? So if my length is, let's say, and radius is something, and they're basically dividing it, and it's 1. So that is 1 radian. So 1 radian would be that arc length is same as the radius, right?
Yeah.
What are you searching?
No, my dad told me to order. My parents are not at home, so I have to text them that I've
Okay.
joined the class.
So one radian is the angle that an arc length of radius subtends at the center. Angle that an arc length subtends at the center. Okay, let me write it only. Okay, 1 radian. And obviously here you can say that one right angle is pi by 2 radian, or you can write it that pi by 2 c. We generally like this only. We don't use c. Okay, now degree to radian, all of these things you know. So okay, yeah. Few important things. Sum of interior angle of an n-sided polygon. N-sided polygon. Okay, it is n minus 2 pi. So that means n minus 2 180 degree. And sum of exterior angles would be 2 pi. Okay, number of diagonals of n-sided polygon, that is n by 2 into n minus 3, or you can write it as nc2 minus n.
Wait, could you give me 1 second? I'm writing this down with you. Also, I think there's someone else in the class.
Okay, let it be.
Yeah. Okay, I got it.
Okay, after that we have some very basic things, for example arc, sector and segment, right? We know center, this is an arc, right? Let this be theta, this is the radius, this is L, so we know L is theta r. Okay, in fact you can also write it like theta by 360 into 2 pi r, because you know this and this would cancel eventually, so I can write it like that, correct? And this is just telling me that circumference if I have, so basically if I have to write arc length in terms of circumference, so circumference into theta by 360, theta is the angle that's subtended by that arc, right?
Mm-hmm. Am I audible?
Yeah.
Yeah.
Okay, also one more thing, since we know for a circumference 2 pi angle is covered, right? For a circumference 2 pi angle is covered, correct? So
Yeah.
if I ask you how much would be covered for some theta which is in radian, so theta c, so this is also in radian only, but let's not write it like that. So for this much, how would it be covered? It would be theta into r, correct? Because for 1, it would be, for example, 1 radian, it would be just r, correct?
Yeah.
Then if you consider this is called as the sector, whose area is theta by 360. This is your theta into pi r square. You can also write it like actually theta by 2r square, because pi by 360 is how much? 1 by 2. So theta by 2r square. Then let's say again some arc, but now let's say this chord. Now this is called as the segment, and this is obviously called as the minor segment, and this particular thing would be called as your major segment. This is minor segment.
Mhm.
Right? Can you try to calculate its area? Yes, very simple. You just have to do, let's say this is r, this is also r, this is theta. So area of segment would be what? It would be area of the sector, right? Which is what? You can calculate that, right? Area of sector
Yeah.
minus the area of the triangle, which is 1 by 2 r square, and sine of the included angle, so sine of theta. Correct? Okay, tell me one thing. Uh, let's say the time is 10:40
Yeah.
in a 12-hour clock. So can you tell me the angle between hour and minute hands at this particular time? Try.
Um. Angle between angle between hour and minute hand at 10:40 in a 12-hour clock. 12-hour, right?
Yes. Yes, yes, yes.
Um. mm, About like 80.
Uh, about
Practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.